Good day, learners. Today we are going to study about acceleration. This is included in the general physics kinematics. Kinematics means object in motion. So, in our uniform motion class, the velocity is constant. The velocity does not change. In acceleration, the velocity is changing per minute, per second, per hour. So it keeps on changing. And the measure of how quick the changes means we are getting the acceleration. That's why the meaning of acceleration is it is the rate of change of velocity. Now, when we are saying acceleration, it does not mean that the object is speeding up or slowing down. Now, if our acceleration is positive, that is speeding up. So the velocity is increasing. If the acceleration is negative, then it is in deceleration. What do you mean by deceleration? Deceleration means that the velocity of our object is decreasing or slowing down. So here, note, if acceleration is negative, then the object is decelerating or deceleration. Sometimes they are using the word retardation, slowing down. Okay. Now, this one is our formula. Acceleration is equal to velocity over time. It is not speed anymore because speed, it doesn't have the direction. While in acceleration, we need the direction. That's why we have positive and negative. We have the velocity and not the speed. So acceleration is a vector quantity. Now, acceleration is equal to velocity over time. If you cannot memorize that one easily, you can transform the formula into what? When our object starts not from rest, there is an initial velocity and final velocity. Then we have this formula here. Acceleration, we have the V for the final velocity and U is the initial velocity. This is the letters of the alphabet. U, V. So that's why U is the initial and the final is a V over time. It's minus difference. It's the difference of velocity over time. Now, sometimes with the V is the final velocity, just like here, but the initial is over time. And this one is my favorite. Acceleration is equal to Vf minus Vi over time. So here you can see that F means final and I means initial. Okay, it's up to you to use your own notation, but when you do the exams in IGCSE, once you have chosen one notation here, you do not mix them. If you use VU, then use VU throughout your computation. Do not mix the Vf minus Vi and then the V sub O here and the V minus U. Do not mix it in your computations. You just choose one notation and use it throughout your workings in your problem. So here we have meter per second square. So you must know the difference between the units of velocity and acceleration. Velocity, these two, the initial and the final, the unit is meter per second. That one is the MKS system. We can have kilometers per hour. We can have meter per minute, meter per hour. But the usual way is MKS, meter per second. Final or initial also is meter per second. Feet per second, feet per minute, miles per hour. So those are velocities. the units of velocity. Now, for acceleration, you must have the square here. If you don't have the square, that is not the acceleration. So, this one is meter per second squared, or this one is meter per second per second. You can have meter per second per minute, meter per hour per second. But if you have the same seconds, you have seconds squared. Minute, you have minutes squared. Like that. Okay. How did we get this one? So let us get that unit here. So for that unit, let's have this one. Okay. So we have acceleration. So for our acceleration, we have acceleration here. The unit of velocity is meter per second. Go. So we have meter per second divided by time, which is also second. Okay, this is division of fraction. How do we divide fraction? So in fraction, we have meter per second here times, this one is the fractional bar, is second over 1 reciprocal. So we multiply this 1 by the reciprocal of s, which is 1 over s. Now you see here, m times 1 is m, and below is second times second here is second squared. 1 plus 1 exponent is 2. So you have meter per second square. Okay. You can have meter per second here and then divide by minute. So the unit of your acceleration is meter per second per minute. You don't square them because they are different when you multiply it. Or you can have meter per second over minute is meter per second minute. That's the unit of acceleration. So the unit of velocity is almost the same as the unit of acceleration. But always remember that in acceleration, the time is squared. Okay, let's have two examples of acceleration. So calculate the acceleration of a car that travels from 0 meter per second to 28 meter per second in 10 seconds. So first write your given. Always write your given. So we have acceleration, in which that is the unknown here. So let's have the initial. I'm going to use a VI for initial, final for VF, and time here for T. So from 0, this one is our initial and this one is the final. So initial is 0 and then the final is 28 meter per second. Always take note of the unit. And then time is 10 seconds, 10s. So let's have our formula. Acceleration is equal to VF minus VI. VF is 28 minus VI. The initial is 0. The initial is always on the right. The final is always on the left. Over 10 here. So acceleration here is 28 divided by 10 is 2.8 meter per second. Is it correct? Not yet. It is wrong because the unit is meter per second. You have to put the second squared here. Put the square there. So it meaning that the car is speeding up at a rate of 2.8 meter per second every second. Okay, 2.8 now. After a second, then it will become 5.6, and then after another second plus 2.8 to that 5.6, and then the speed is increasing and increasing and increasing because that is positive. Number 2, a train initially moving at 12 meters per second. So this one is our initial velocity. Speeds up to 36 meters per second. That's the final velocity in 120 seconds. So this one is our time. So what is its acceleration? So in our given here, our acceleration is the unknown. So we have the initial, we have the final, and we have the time here. So 12 is initial, 12 meter per second here. VF is 36 meter per second, the same because they are velocities. And time is 120 seconds here. So we have our formula, acceleration is equal to VF minus VI over time. So here, VF is 36 minus 12 over time of 120 seconds. So our acceleration here is equal to 36 minus 12 is 24, and then this is 120. We divide that one, so we have 0.2 meter per second squared. This one is meter per second, this one is seconds. Meter per second, they are like terms. So we can subtract 36 and 12 to have 24 and copy meter per second. Then divide, so you have meter per second squared.